So with the ER model, we can draw so many different entities for our application domain. However, in the real world, some entity can be important, some can be less important, and some others may even depend on the other entities. So formula to define this kind of entity which depends on some other entities, we introduce the concept of the working entity set in this page. So in the ER model, the working entity set can be so weak, and their key attributes can come from other entities to which they are related to. It can be caused by many reasons. For example, it can be because the data we have in the real world are hierarchical, or it can be caused by splitting these multi-way relationships into binary ones. At the bottom, we have an example. Let's assume we have two entities. The first one is the employees. So the employee works for some companies, and the employer of the company may create or may generate some insurance policy for the employees. And for most of the policies, they may allow the employee to declare someone else as their dependents. And we want to model this kind of information with the ER model. Therefore, we can draw the employee entity, as shown here, is a rectangle, and the employees have three attributes: SSN, name, and not. So among them, SSN will be the key, so we have one line here. We have a relationship, the policy. This policy has a attribute, is the cost of the policy for the insurance. And we have another entity, is a dependence. The dependent has two attributes, the P name, dependent name, as well as age. So by the policy relationship, we can have a line connects to employees, one line connects to dependents. So for the line pointing to the employees, we have one rounded arrow. So you know what it means, right? It means the referential integrated constraint. Whenever we are referring to employees from dependents via policy relationship, we need to make sure first the employee should exist. Second, there exists only one single employee in the tables, right? Besides the referential integrated constraint, we can also see some difference in this ER diagram. The first part is a P name. It is underlined. However, this underline is dashed, right? This underline is different from the underline used for SSN. This P name is dashed because it can serve as one part of a key for dependence. When we define the key for dependence, we need to borrow the SSN key from employee. This SSN together with the P name we define as a key for dependence. In other words, this P name is not enough to serve as a key for dependence. We have to borrow the SSN from the employees they depend on. They together will differentiate different dependents. This is one difference. Another difference is for dependents, this entity. We see this rectangle is so thick, the borders. In some representation, we can also use a double rectangle. Outside this, to highlight, this entity is a working entity set. And besides this, for the relationship with the policy, normally we use a diamond to represent relationships. However, for the policy here, we use this double diamond. With the double diamond, we can highlight it is a relationship between a working entity set and the entity which depends on it. So therefore, when we draw the working entity set, we need to pay attention to, first one, the key for the dependence. One part of the key should be underlined with dashed lines. And this rectangle should be highlighted. And you can also draw with double rectangles. It's also okay. And for the relationship, you can use double diamond to highlight it is a relationship for the working entity sets. You may still wonder what does this mean. This P name should be combined with SSN from the employees that together can serve as a key for dependence. Maybe I can show you with the example. Let's assume we have two employees in a company. And we have an employee, like his name is Michael. And this Michael has SSN like 1, 2, 3. Let's assume like this. And Michael is an employee in a company. And for the Michael, he has a son. His name is Sam, for example. Name is Sam, and his age is 5 years old. And the company creates an insurance policy for Michael, and Michael declares Sam as his son and dependents involved in the policy. Besides Michael, let's assume we have another employee inside the company, like John. His SSN is 234, like this. For John, let's assume he also have one dependent. His name is also Sam, and the year and the age is also 5 years old. Then how can we differentiate these two Sams? The name unknown is not enough to differentiate them, right? All of these Sam depends on their father in the insurance policy. So when we talk about the Sam, this Sam we have to say that this Sam is from Michael's family. He's Michael's son, and his name is Sam. It's not other names, right? For this Sam, we have to say this Sam is from John's family. His father is John, and his name is also Sam in the insurance policy. You can see this Sam unknown is not enough to differentiate the different dependents. We have to combine the same name with information from their father's information, like SSN. Together we serve as the key for dependents. Then how can we decide which entity should be the working estate? And we have one guidance here. Let's assume we have an entity state. We can say this entity state is weak if, in order to identify entities inside the state uniquely, we have to follow one or more of these magnitude 1 relationship from this entity, and also include the keys of these related entities from the owner entity sets. We can name, like for example, this dependents as the working entity state. We can name these employees as the owner entity state. When referring to data in the dependents, the working entity state, we have to combine these keys from these employees together with a PNAME. They can differentiate different dependents inside the dependent set. So when you draw your ER diagram, you need to ask yourself, can any of these entities in your design will be the working entity set? Generally, in our ER model, for the same owner entity set like employees, we may have multiple working entity sets. Besides dependents, we can also define some other working entity set. Depends on it. It's a node. We know this multiple working entity set depends on the same owner entity set.